Okay, and welcome. And the purpose of this presentation is to help you guys review the unit circle and how to fill out the unit circle quickly and efficiently with regard to a couple things. The degree measure of the angle, the radian measure of the angle, as well as the ordered pair that represents that point on the circle for that specific angle and radian measure. We've covered this in class, but this is a really good template for you to practice with, to really get familiar, not really to memorize, but through repeated practice to get really, really comfortable. So the first thing we're going to do is we're going to go ahead and fill out the quadrantals, and by quadrantals I mean the angles and the points that are on the x or y axis but not actually in a quadrant. So we're looking at really 4 of them, but 5 kind of if when you make one complete round around the circle. So here's the first one, quadrantal. Here's the second one. Here's the third one. Here's the fourth one. And then back again, here's the fifth one. Remembering that a unit circle has a radius of 1. Okay, so we're going to come over here and just get a little bit zoomed in, and let's go ahead and begin. So right here, when we start over here, the initial and terminal side of this angle are at the same spot, so essentially that angle is 0 degrees and 0 radians, and with a radius of 1, this would be the point 1, 0 on the unit circle. Okay, if we move over here just a little bit, now we've gone 90 degrees right here. Okay, so this angle right here is 90 degrees, and the point would be 0, 1. Now in terms of radians, we know that 180 degrees, which is a half circle, if you take that and divide by 2, you get 90 degrees. Well, 180 degrees is the same as pi radians, so if I take and divide that by 2, I'm going to get pi over 2 radians for that quadrantal. Okay, if we move over here to the next quadrantal, now we know we've gone 180 degrees, which is pi radians, and with the unit circle always being a radius of 1, this is -1, 0. Okay? So if you take note about this, and I zoom out just a little bit, the unit circle is really divided into 4 quadrants, into quarters. We know a complete rotation around the circle is 360 degrees, so half is where I got the 180 from. Half of that is the 90. So each quarter of the circle, we're going an extra 90 degrees. So when we come down here to fill out this quadrantal at the bottom, we know that it's 270 degrees, and the point is 0, -1. And in terms of the radians, if you noticed, if we zoom out just a little bit, we start at 0 radians, and we go pi over 2, and then we're actually going another pi over 2. So this would over here would be really 2 pi's over 2 radians, but the 2's cancel out and you get pi radians. So I'm going an extra pi over 2 radians each quarter of the circle, which would then mean that down here I'm at 3 pi over 2 radians. Okay, and then we come again and we come back to where we started, but we're completing the rotation. The point on the circle doesn't change, but in terms of my degrees, if we've gone 1 full rotation in a counterclockwise direction around the circle, this would be 360 degrees. And if you think about it, this is, we've gone 1 pi over 2 rotation, radians, 2 pi's over 2, 3 pi's over 2, 4 pi's over 2, but 4 pi's over 2 radians reduces to 2 pi radians. And we've thus created and filled out all the quadrantals for the unit circle. So now we're going to go ahead and we're going to zoom in on the first quadrant. And I'm going to help you fill out the first quadrant in terms of degrees and radians, and then I'm going to have you pause the video and see if you can't use that first quadrant to help you fill out quadrants 2, 3, and 4 just in terms of the degrees and radians. And then what we'll do is we'll come back and we'll talk about the points on the circle and how that relates. Okay, so this we're going to talk about this first angle right here in degrees and radians, and that would be 30 degrees. And if you go ahead and that didn't come out so well, so let's go ahead and erase that and rewrite that. So we have 30 degrees, okay? And if you take 180 degrees and you divide by 6, you get 30 degrees. So over here, the radians would be pi over 6 radians. I don't know why that's not, there we go. Okay, this next angle would be 45 degrees. It's halfway in between 0 and 90. And if you take 90 and divide by 2, you get 45. So if you take pi over 2 and divide by 2, you get pi over 4 radians. Another way to think about it is 180 divided by 4 is 45, so pi divided by 4 would be equivalent to 45 degrees. And then the last angle in this first quadrant, that's one of the important angles, is 60 degrees. And 60 degrees comes from 180 divided by 3, so pi divided by 3 radians would be equivalent to 60 degrees. So right now what I'm going to have you do is I want you to think about reference angles and how all the angles in a quadrant can refer back to an angle in the first quadrant based on the distance or the rotation from the x-axis. And so I want you in a second here to pause the video and fill out quadrants 2, 3, and 4 to the best of your ability. And then you can press play on the video again if you need some more help or to see it and check your answers with what I came up with. So at this point, please go ahead and pause the video and fill out just the angle and radian, so the degree angle measure and the radian angle measure for the remaining parts that we have on this unit circle. Okay, so now let's go ahead and look at filling out the second, third, and fourth quadrants in relation to just the degrees and radian measures. So the order in which you do this really makes no difference, but here's where I'm going to go. So I'm thinking right now in my brain that this angle right here has a reference angle of 30 degrees. And so if I'm at 180 degrees and I have a 30 degree reference angle, then this angle has to be 150. Okay, so right here I know that this angle is 150 degrees. And in terms of my radian measures, again, 30 degrees is a pi over 6 angle. So this is an angle whose reference angle is pi over 6. Pi over 6 before pi, and if you think about common denominators, we can call pi 6 pi's over 6. So a pi over 6 before 6 pi's over 6 would be a radian measure of 5 pi's over 6. Okay, I'm going to repeat that same process with the other two angles. When I come down here, this angle right here is an angle who has a reference angle of 45 degrees, or pi over 4. 45 degrees before 180 is 135. And pi over 4, and again, if you think common denominators, now let's make that 4 pi's over 4. So a pi over 4 before 4 pi's over 4 is 3 pi's over 4 radians. So I know that this angle is 135 degrees, and that it's also 3 pi over 4 radians. I'm going to go again one last time for quadrant 2, and I know that this angle right here is an angle who has a reference angle of pi over 3. If I think about degrees, that's 60. 60 degrees before 180 is 120. And since I'm talking about a pi over 3 angle right here, reference angle, let's make this 3 pi's over 3. And a pi over 3 before 3 pi's over 3 is 2 pi's over 3. So this is 2 pi over 3 radians, and we also said 120 degrees. So essentially that takes care of the angle and radian measures, the degree, angle measures and radians and degrees for quadrant 2. We're going to go ahead and repeat that same process for quadrant 3. And again, the better that you get at this, the less help you're going to need. But it takes practice. There's a lot of thinking involved. All right, so if I come down to quadrant 3, let's make quadrant 3 even a little bit bigger. Okay, and I'm going to repeat the same thing you heard me say in quadrant 2. This angle right here is an angle whose reference angle is pi over 6, but now we're pi over 6 past pi, or 6 pi's over 6, and we're 30 degrees past 180. Well, 30 degrees past 180 is 210, and pi over 6 past 6 pi's over 6 is 7 pi's over 6. So I'm going to call this angle a 7 pi over 6 radian angle measure, and then we said this is 210 degrees for that angle right there. Okay. Then for the next one, we know that this angle right here is 45 degrees past 180, which is 225. We also know that that's pi over 4 radians past 4 pi's over 4, and pi over 4 past 4 pi's over 4 is 5 pi's over 4. So we're going to call this angle 5 pi over 4 radians, and we're going to call it 225 degrees. Okay, the last angle, and really there's other angles in these quadrants, but these are the ones that, that we need to know by heart, that are based on the special right triangles back from geometry. This angle right here is now 60 degrees past 180, which is 240 degrees. It's also pi over 3 radians past 3 pi's over 3, and pi over 3 past 3 pi's over 3 is going to be 4 pi's over 3. So this would be 4 pi's over 3 radians, which is also going to be equivalent to 240 degrees. Now we're going to go ahead to the fourth quadrant, the last quadrant before we start talking about the ordered pairs that represent these angles on the circle, these points on the circle. Okay, so again, I'm referencing back to angles in the first quadrant, and I'm basing these angles off of my x-axis. So I come here, and if I look at this first angle right here, okay, this is a 30 degree, that this angle has a reference angle of 30 degrees, okay, and 30 degrees before 360 is 330 degrees. This is also a pi over 6 angle. So I could call this right here 12 pi's over 6, because 12 pi's over 6 is 2 pi. So I always want to get those common denominators with regard to what my reference angle is. Well, a pi over 6 before 12 pi's over 6 is 11 pi's over 6. So this angle right here is 330 degrees, and it's also 11 pi over 6 radians. Okay? This next angle right here is it has a reference angle of 45 degrees. It's 45 degrees before 360. That's 315 degrees. It's also pi over 4. So if we think about a common denominator, 2 pi is equivalent to 8 pi's over 4. A pi over 4 before 8 pi's over 4 is 7 pi's over 4. So this angle would be 7 pi over 4 radians. And we said also that it was 315 degrees. Okay, last angle in this fourth quadrant that needs to be filled out, we're looking at 60 degrees, 60 degree reference angle. So it's 60 degrees before 360 degrees, which is 300 degrees. That's a pi over 3 radian reference angle. So that would make this 6 pi's over 3 is equivalent to 2 pi. So if I think about this as 6 pi's over 3, a pi over 3 before 6 pi's over 3 is 5 pi's over 3. So there's 5 pi over 3, and then also 300 degrees. And if we zoom out and we look at our measures, one of the things in class that we talked about as well that would be kind of cool to see on this is we talk about our bow ties. And our bow ties, so essentially if I draw the 30 degree bow ties, right? You're looking at all angles 30 degrees right here. You're looking at 150 degrees. You're looking at 210 degrees. You're looking at 330 degrees. All of those angles have a reference angle of 30 degrees. And so we base that off of the x-axis, and we're able to find the angle measure in degrees as well as in radians. And we can go through and see the 45 degree bow tie angles. Okay, and it's getting a little bit confusing to look at this whole unit circle all at one time, but definitely the more you practice, the better you're going to get. We're now going to look at filling in the points on the circle, and we're going to start with the first quadrant, and I'm going to walk you through how to fill out the points on the circle, the non-quadrantals, for the 30 degree, 45 degree, 60 degree reference angle. And then I'm going to pause the video and ask that you pause and see if you can't fill out quadrants 2, 3, and 4 based on what you did in quadrant 1. So the first thing that we need to review is our special right triangles. So up here I'm going to draw my 30, 60, 90 special right triangle, which again, now we know that 60 degrees is equivalent to pi over 3 radians and 30 degrees is pi over 6 radians. Okay, and from geometry, hopefully remember that the short leg can be anything. So let's think about our, I guess we could just make this 1. So if we make our short leg 1, our hypotenuse is double that, which would be 2, and then our long leg, which is across from 60, would then be 1 square root of 3. Okay, and the second special right triangle we need to review is the 45, 45, 90 isosceles right triangle. Okay, here we have 45 degrees, which is the same as pi over 4 radians. So that's a piece that you didn't discuss back in geometry. Okay, and if we make the legs each 1 unit, the hypotenuse is 1 square root of 2 units long. So let's see how this plays out in our triangle. So what we're going to do, or our unit circle, excuse me. So what we're going to do right now is we're going to look in just this first quadrant area, and I'm going to talk about the 30 degree reference angle, the 45 degree, and the 60 degree. So the first thing I'm going to do is I'm going to go ahead and create my right triangle. This is 30 degrees. And the thing about this that we know is we now know we're in a unit circle. We know that the radius is 1 unit. So now if we know our hypotenuse, our short leg, our hypotenuse is double of our short leg. So our short leg now would be a half, and our long leg, because here would be 60 degrees, our long leg would be root 3 times as big as our short leg. So this would be 1/2 root 3 or root 3 over 2. So right now I can go ahead and fill in the ordered pair. If you think about it, you've gone over root 3 over 2 units, and you've gone up a half unit when you have a 30 degree angle in your first quadrant. So this ordered pair would be root 3 over 2. Let's move this back over here. Root 3 over 2, comma 1/2. Okay? Now, similarly, so let's go ahead now, and if we come back up here, let's see if we can erase that. There we go. So take that away. We have our point. Okay? I'm going to skip the 45 degree angle for just a minute so that you can see the relationship with the 60 degree angle. So what I'm going to do right now is I'm going to, from this point on the circle, drop my altitude, create a right triangle. This angle right in here would now be 60 degrees. Okay? And we know that the radius is 1 because we're dealing with the unit circle, and your 30 degree angle is now up here. Well, your hypotenuse is double of your short leg. So now your short leg, the 1/2 is down here, and then your long leg right here is square root of 3 times as big as your short leg. So this over here, this whole piece right here would be 1/2 root 3 or root 3 over 2, which now makes, if you think about it, this point right here on the circle, you've gone from the origin over a half and up root 3 over 2. So this point would now be 1/2, comma root 3 over 2. And not a coincidence that the 60 degree angle, the point on the circle, is 1/2, comma root 3 over 2. And the one for 30 degrees is just the opposite of that, root 3 over 2, comma 1/2. And one of the things that helps me, you know, you're going to need to know these numbers and get pretty familiar with them. You know, you saw them in geometry, and now we're seeing them again with the unit circle. But I know root 3 over 2, so I know root 3 over 2 is bigger than a half. So if I visually think about my unit circle, if I deal with the 60 degree angle, my x value is smaller than my y value, thus the 1/2, comma root 3 over 2. If I go back over here and I draw in my triangle for my 30 degree angle, I now have a situation where I have a longer x value than I do y value, thus the root 3 over 2 as my x and the 1/2 as my y. So now let's go ahead and move these triangles. Oops, I gotta get rid of this triangle. So now let's look at the 45-degree triangle. And so what I have over here is this angle, and here would be 45 degrees. My radius is 1. So if I go back up here and I look at my 45, 45, 90 isosceles right triangle, if I know my legs, I multiply by root 2 to get to the hypotenuse. If you're going the reverse way, you divide by root 2. Okay, so essentially, since your radius is 1, then each of these legs you would divide by root 2, so you'd have 2 legs, and your ordered pair would be 1 over root 2, comma 1 over root 2. So that would be totally fine for the ordered pair for that point on the circle, but we also know if we rationalize 1 over root 2 and we get rid of the radical in the denominator, we get root 2 over 2. So whichever one you're more comfortable with, as long as you identify that both are the same, would be fine with regard to writing that point on the circle. Either 1 over root 2, comma 1 over root 2, or root 2 over 2, comma root 2 over 2. Alright, so, oops, and I did not want to delete that. So let's go ahead and rewrite that one more time. Root 2 over 2, comma root 2 over 2, or 1 over root 2, comma 1 over root 2. So now what I'm going to have you do is I'm going to go ahead and ask that you pause the video. And again, this isn't the first time you guys have seen this is a review, and see if you can use that knowledge to fill out the other angles that have the same first quadrant reference angles with regard to the points on the circle. Okay, and notice, not a coincidence either, about what was written in each quadrant: positive, negative, positive, negative, positive, negative. We're going to start thinking about x and y values, which are positive, which are negative, in the next segment. After we go over the points on the circle, we'll be talking about how these points relate to sine and cosine. So please go ahead and pause the video right now and fill out quadrants 2, 3, and 4, the remaining pieces of the circle, which would be all the missing points on the circle. Okay, so now let's go ahead and see if you were correct, or if you needed some help, let me help you. We're going to go ahead and fill out the points on the circle for the remaining 3 quadrants. Again, when we first talked about this in class, one of the things to notice is if I come, if I come over here and I draw in my triangle for my 30-degree angle, if I notice over here this 150-degree angle, which is really this angle, but it has a reference angle of 30 degrees. That's how far it is away from 180. So if you think about what you're dealing with the same 30, 60, 90 right triangle that you had over in the first quadrant. And so the point that you had over here for 30 degrees is going to be the same as the point that you have for 150, because you're dealing with the same triangle. Okay? The only difference is over here you went over positive root 3 over 2 up a half. Here you're going to go over negative root 3 over 2 up a half. So when we go ahead and write in our point, it's going to be negative root 3 over 2, comma positive 1/2. The same can be said for the triangles that are created. Here's my 45, 45, 90, and my 135 degree. This angle in here is 45 degrees. It's the same triangle. That's where the bow ties come from. So when I go ahead and fill that out, instead of it being root 2 over 2, comma root 2 over 2, it's going to be negative root 2 over 2, comma root 2 over 2. And then finally, the same can be said for my 60-degree angle. 120 degrees, which is really this angle here, has a reference angle of 60 degrees, so you're talking about the same triangle. But instead of positive 1/2, comma root 3 over 2, we're going to have negative 1/2, comma root 3 over 2. Okay, so that's quadrant 2. We're going to go ahead and move down to quadrant 3. And again, thinking back to the bow ties, this 210 degree angle right here is the same triangle as the 150 degree angle, as the 30 degree angle. So it's also going to have the root 3 over 2 1/2, but now both the x and the y are negative. So this would be negative root 3 over 2 comma negative 1/2. For the 45, 45, 90, it would be negative root 2 over 2 comma negative root 2 over 2. And then finally, for the 240 degree angle, it would be negative 1/2 comma negative root 3 over 2. Okay, so what you're seeing is, and we can go back and talk about this as well, in the first quadrant, the x and the y values are positive. You're going positive, positive. In quadrant 2, you're going negative, positive. So all your x values are negative, but your y values are positive. In quadrant 3, you're going negative, negative for all of them, so your x and your y values are negative. Let's go ahead and see what happens when we get to quadrant 4. Okay? So for quadrant 4, again, this angle 330 degrees is the same triangle as the 30 degree, the 150 degree, the 210 degree. So we're using root 3 over 2 and also 1/2, but now it's positive root 3 over 2 comma negative 1/2. For the 45, 45, 90, it's it's positive. Let's go ahead and erase that little, start to be a negative here, if I can get that. Oh, and erase that too. Okay, so let's rewrite this. This was root 3 over 2 comma negative 1/2. This is root 2 over 2 comma negative root 2 over 2. And then finally for this one, this is going to be 1/2 comma negative root 3 over 2. And again, noticing that you're going positive x, negative y, so all of your x values are positive, but your y values are negative. This is not something to memorize. I know there's all kinds of tricks to memorize the unit circle. This is going to become more and more comfortable to you through repeated practice and through thinking, and everything is based off that first quadrant because those are your reference angles, and that's what you're referring back to for quadrants 2, 3, and 4. The last thing we're going to look at and review, really, from what we've done in class is how sine and cosine relate in the unit circle. So we're going to go ahead and come down here, and we're going to go ahead and draw in the reference triangle for 30 degrees. And while this is 30 degrees, it's also an angle, so we can call it essentially theta. Okay? And we know that the radius is 1, and even though we do know that this x value is root 3 over 2 and the y value is 1/2, we're going to call this x and we're going to call this y. Okay? And we're going to come over here and we're going to say that we know the cosine of 30 degrees is equal to x over 1. So essentially, x is equivalent to the cosine of 30 degrees. So that is your x value. Okay? And if we do the same thing for the y, we're going to say sine of 30 is equal to y over 1. So essentially, y is equal to the sine. Now let's go back here for a second. I kind of squish things in a little bit. The sine of 30 degrees, and that's right there. So if we generalize, we know that in a unit circle, if we replace 30 with any angle with theta, we can say that for any point on the circle x comma y, that's really, x is really, and actually, if we come back up here, one of the things to notice is that while 1 is your radius, when we cross multiply, that really ends up being 1 cosine of 30 and 1 sine of 30. So on any point on the unit circle, we know that your x value is r cosine of the angle, comma r sine of the angle. And it just so happens that your radius is 1, so it ends up being cosine of theta comma sine of theta. So if we come and scroll out just a little bit, knowing this information, if I were to ask you, so essentially to summarize what we just said, we said for any point on a circle x comma y, it goes r cosine theta comma r sine theta. Now in a unit circle that r is 1, so that would cancel out. So for example, if I ask you for the sine of 150 degrees, if I go to the circle and I go to where 150 degrees is, I know that sine is my y value. So the y value right there is a half, so I would say that that's equivalent to a half. And sine of 150 is also the same as the sine of 30, because the reference angle is 30 degrees, and then you have to think about if sine or cosine is positive or negative in that quadrant. The very last piece to talk about is why this positive negative piece was in each of the quadrants. Well, it's talking about sine and cosine. So when we think about positive and negative, well, first off, in this first quadrant, none of these points are negative, they're all positive. We know that the x value is equivalent to your cosine value of the angle, and your y value is the sine. So positive, negative, sine, and cosine are positive, so the reciprocal values secant and cosecant are positive. And the other thing, too, that we know is we know that the tangent of theta is equivalent to sine of theta over cosine of theta. So when sine and cosine are both positive, then essentially all is positive in the first quadrant. Okay? In the second quadrant over here, and actually what we could do over here too is we could go ahead and put an ordered pair in here that says positive comma positive. Okay? Over in the second quadrant, it's negative comma positive. In the third quadrant, we have a situation where we're negative comma negative, and in the fourth quadrant, we have a situation where we're positive comma negative. Okay? So if we come back up here to the second quadrant, we know in the first quadrant, we know that all trig functions are indeed positive. In the second quadrant, if you think about it, your x value is negative and your y value is positive. So the fact that your y value is positive, that means that your sine is positive, and also then your cosecant will be positive, and then it implies that everything else is negative. And the reason everything else is negative is because we know that tangent is sine over cosine. We know that cotangent is the reciprocal of that, so those are both negative. And then we also would know that your cosine and your secant would be negative. So if we go through, instead of defining what everything is, let's define what's positive and imply that the rest is going to be negative. Okay? So if we come down to the third quadrant and we find out what's positive and what's negative, so let's try and define what's positive, and everything else would be an implied negative. So if both your cosine and your sine values are negative, their reciprocal functions of secant and cosecant are negative, but what would be positive would be tangent and its reciprocal cotangent, because what you have is you have y over x, which is sine over cosine, which is your tangent. And then finally in the fourth quadrant, you have a situation where your cosine is positive but your sine is negative. So in terms of what's positive, we know that your cosine and its reciprocal secant are positive, but everything else is going to be negative. Tangent would be negative because that's sine over cosine. Cotangent would then be negative. Sine and cosecant would be negative as well. And then, interestingly enough, the last piece to point out, because when we think about what the sine of 150 is, we could go ahead and go to our unit circle if we've written this all out. We can go to 150 and we can say, okay, sine's the y value, we know that's a half. Or we could say instead, well, we know that sine of 150 is equivalent to sine of 30, and knowing our special right triangles, we know that the sine of 30 degrees is a half, and then we just have to think about whether or not it's positive or negative. So is 150, it's in the second quadrant, and in that second quadrant is sine positive or negative? It's positive. And so if we look at the graph right now, if we go counterclockwise the way we measure positive angles, we have A, S, T, C. And oftentimes in math what we think about, and I'll make a little grid in the middle here, is we say all students take calculus. And what that means is in the first quadrant, all your trig functions are positive. In the second quadrant, just your sine and your cosecant, which is the reciprocal of sine, are positive. In the third quadrant, your tangent and cotangent are positive. And in the fourth quadrant, your cosine and your secant are positive. And so when we start doing more and more problems like this, so let me give you one more and then we're going to wrap things up. So what if I change this instead to the cosine of 150? Well, the cosine of 150 is equivalent to the cosine of 30, but here's what we have to think about. In the second quadrant, which is where this would be, that's your x value, that's negative. So when we take that into account, we're going to think about what the cosine of 30 is, but we're going to tack on that negative, and that's where we get negative root 3 over 2, which, if you go back up to your graph, your unit circle representation, and we go to 150, there's your x value, which is your cosine, and sure enough, it's negative root 3 over 2. So the all students take calculus is going to be really, really important when we start doing more of this, or as we start doing more of this, evaluating sine and cosine of an angle and keeping in mind which quadrant it is. So I hope this was a good review for you. Remember that the more practice you get, the more comfortable you're going to get. There's a lot of thinking, and you will learn this through repeated practice, and there's no easy way to memorize it. You want to be able to apply this in my class as well as beyond.